Squirrel cage induction motor, rotational direction. Now, how do we determine the rotational direction of a three-phase motor? Well, really, we have only two different options available to us. Aside from what you may have been told out in the field, there is no standard direction that a motor will turn when first hooked up to three-phase. Our options range from the very basic bump, which is simply us energizing the motor for a fraction of a second and then noting visually which direction the shaft turns. Now, you can do this when there's no mechanical load connected on the motor. You could do it on fans sometimes, or really the fan won't care which direction it's turned, or something cheap. Essentially, you do this method on something that would not be damaged, and you have a 50-50 chance of being correct. Now, if the motor is turning in the wrong direction, all we do is swap two of the incoming line conductors, and doing that will then change the direction of the shaft. Now, sometimes we have equipment that cannot be bumped, and that's because the motor is directly connected to a compressor or something that's expensive, that's not belt driven, and if we were to apply the wrong rotation direction, we could actually damage it. And in those situations, we need to use some specialty direction tools. They're really just small specialty built multimeters that are for a specific application. So compressor motors, gearboxes, anything that you look at and you think, whoa, that looks expensive, you don't want to bump. So here's a motor rotation indicator. It's one of two devices that we would need in order to accurately determine the direction of rotation of a motor the very first time we energize it. So this item comes with three leads. It's a very basic display. There's no buttons on it, and it connects to the motor leads of the motor we want to investigate. So here's my motor. I've got the three T terminals coming out of the junction box for connection to the motor rotation indicator. And I'm going to connect the red, yellow, and blue leads to T1, T2, and T3. Now, as soon as I do that, inside this little yellow meter, there is a battery. And what it's going to do is it's going to introduce a very small amount of current into the windings of the motor. And based on what it senses coming back, it will then tell me what direction the motor will turn if I were to connect phase A to T1, phase B to T2, and phase C to T3. So in this case, the meter's telling me the motor will turn in a clockwise direction. Okay, well, that's sort of half of the story because I now need to know what the actual three-phase rotation is on the supply that I'm intending to connect to. Now notice on this meter, it shows me the direction of rotation and it says the word good. Now it's really a basic scenario here. When I hook these three up to a live source, inside is a disc with a red circle. And as soon as I energize it, the disc is going to start spinning because it's essentially a small electric motor in there. I'm going to energize it for a split second and determine visually what direction the disc is spinning. Is it spinning in the right direction, as in the arrows indicating that we have correct phase sequence? Or is it rotating in the reverse direction, which is not what we would want? And that's what we're checking for. So we hook it up to our three-phase supply of whatever we're planning on connecting the motor to, and this phase rotation meter will then indicate if the phase sequence matches the colors of the conductor, or if they have been mistakenly reversed somewhere upstream. Now, this is quite common to occur where I have a red, a black, and a blue wire, but they're not actually phase A, B, and C. Maybe someone accidentally terminated the blue wire onto the B phase. And so that's the reason for having this second meter. Once I've determined what the correct sequence is ABC for the colors of the conductors, that's when I can then bring my motor and connect it up based on the two readings of the two different meters. And that's how we would get the correct rotational direction on a motor the first time.